All right, we have reached our last new topic, and this is section 5.5 in our textbook, and it's a topic called integrating by U substitution. Make sure your phone is put away and take good notes. This is a little confusing, I think, the first time you learn it, but once you get the hang of it, you'll be all right. If you do intend to take Calc 2 next semester, which I hope you might consider, this will be used a lot. This is a really important topic in Calc 2, so let's get a good handle on it for now. What this does is this allows us to integrate more complicated functions, to find more complicated antiderivatives. And this is sort of the backwards version of using the chain rule. Remember, we used chain rule when we were taking derivatives and we had an inner and an outer function. So this is kind of the analogous version of that for integration. So let's see how this works. So when you're working through these problems, what we're going to do is we're going to start by choosing an expression in the integral for u. And the idea is we want to replace everything that's in the integral in terms of x to something in terms of u. Oftentimes u is going to be the inner function. So remember with function composition, if you think of the inner and the outer function, the one that you would think of that's on the inside of the other function is going to be your choice of u. So in this case, that would be x plus 2. Then the next step is to take the derivative of that expression you just chose for u, and I want you to write du dx when you take the derivative. So du dx in this case would be just 1, because that's the derivative x. And then in that expression, you're going to solve for dx. And that what you get for dx is what we're going to replace for dx in the original integram. So think about du dx. You can think of it as division for the purposes of U substitution. So I'm going to multiply both sides by dx to make that happen. And that gives me du equals dx. So let me go back to my integrand and let's rewrite it in terms of u. So we have the integral of, in place of x plus 2, we get u to the 5th power. And then the dx gets replaced with what we just said it was equal to, which is du. So that gives me u to the 5th du that I'm integrating. So now u to the 5th with respect to u, the antiderivative would be u to the 6th over 6 plus c. And then last step is go ahead and replace u with what it was equal to, which was x plus 2. So we have x plus 2 to the 6th over 6 plus c. And that is going to be our antiderivative. Let's look at another example using this technique. So in number 2, think about what would be the inner function here, and you want to choose that to be the u. So it looks to me like 1 plus x squared is on the inside of the radical. So I'm going to use that as the u. Then I'm going to say du dx equals, the derivative of 1 plus x squared will be 2x. So notice in this integrand that I have 2x dx right here in the integrand. So I'm going to take this equation, because notice that it contains a 2x already. I'm going to multiply the other side by dx. And what I want you to observe is that the 2x dx is equivalent to du. That's the substitution I'm going to make. So my integrand becomes the integral of the square root of u, and then in place of 2x dx, I'm just going to put du, and that's the substitution. Then we're going to integrate it like normal. The idea is to make this into something easier to integrate, something we can work with. So this becomes just a straight power rule problem. The integral of u to the 1/2 is basically what you're looking at, du, and that becomes u to the 3/2 over 3/2, which becomes 2/3 u to the 3/2 plus c. And then last, make sure you go back and replace u with 1 plus x squared, because we want our answer to be in terms of x, not in terms of c. And there's my antiderivative for that one. Let's look at number 3. So I'm going to let u equal what's on the inside. It looks to me like we have a radical again, so I'm going to let u equal 4x minus 1. I'm going to take the derivative of that, so du dx is just 4. Now, what I would do is go ahead and solve for dx. See how I have a dx in this equation? I'm going to try to get dx out of this derivative equation. So I'm going to multiply dx to the other side, and then I'm going to divide by 4. So dx is going to get replaced by du over 4. So my integrand becomes the integral of the square root of u times du over 4. And then I'm going to put that over 4 is just a constant multiple. So I can move that to the front. That's a multiple of 1/4 times the square root of u du, which is 1/4 times the integral of u to the 1/2 du. In other words, the typical rules for integration always apply still apply. If I'm multiplying by 1/4, that's a constant multiple. I can move that to the front of the integrand, no problem. So now I'm going to find the antiderivative. So I get 1/4 times u to the 3/2 over 2/3, which becomes, over 3/2, which becomes 2/3. And then if you want to simplify this, you can, but you don't have to. Let's see, this will be 2 over 6 times u to the 3/2 plus c. And then finally just replace u with what we substituted in the first place, which was 4x minus 1 to the 3/2 plus c. And so that is going to be the antiderivative for the original problem we started with. And we can always check these, just like always when we integrate, by taking the derivative and to see what we come up with. But this should be it. This should be our antiderivative, and we'll do lots of practice with this in class tomorrow. So be sure to bring your notes with you.